Thanks, everyone, for joining us. In my opinion, this is a historic moment, and here is why. Have you ever seen Palo Alto Networks and Cisco under one roof, like co-presenting together on one stage? At least I have not seen so far in my years of experience. Neither in Cisco Live nor in Ignite, but at Ignite, this is the first time both Cisco, my old friend and colleague, Maurizio, and I are co-presenting. And the people who are making this happen is you guys, the joint customers who are making this happen. So thanks so much for that. I think in the interest of joint customers, we'll break any barriers that comes on the way. So with that, let's get going. Before I start, I would like to know who is in the audience. So tell us a little bit more about where you are on your ACI journey. How many of you have implemented ACI in production? All right, about 30% of you. How about Cisco ACI in the lab yet, but not in production? All right, about 15, 20%. Third option, I'm still evaluating SDN solutions in the market. All right, maybe most otherwise, all right. The remaining looks like you needed a place to crash, so welcome. When you walk out of this door, I want to make sure that you have a thorough understanding of these three things. The first one, you will know how Cisco ACI and Palo Alto Networks Service Insertion works together. You will know everything about our latest and greatest integration, the most advanced one that we have developed in the market yet, and how customers benefited from the integration. Unfortunately, we do not have a customer on stage yet because of some travel advisory they got from their company that Barcelona, it's a risky place right now to go. So the travel was avoided. But I have a customer slide, and I'll be the one presenting the use case where they deployed our integration and how they benefited from it. So with that, let's kick it off. And I would like to invite Maurizio on stage to talk about ACI fundamentals. For those of you who are new to ACI, have not deployed ACI in production yet, so for some of you, it might be a repeat, but it would be a good refresher. Maurizio, all yours.
Thanks, Jaimin. OK, so allow me to explain to you what ACI is. I mean, for those of you who have it in production, maybe it's a bit repetitive, but at least everybody is on the same page with regards to ACI's technology. So as the slide depicts, ACI is a fabric made of multitude of switches. We normally call these spines. And then you could have 1 or 2 tiers of leaf switches. So this is what you would put in place in your data center to connect servers and virtual machines to it, as well as routing devices to connect to the outside. And the entire fabric is managed through the controllers that here are depicted with this icon. And that's where you would normally interface with the UI or with automation tools or with the REST API calls and so on. So it's an infrastructure that is designed for automation from day one. There's been a lot of focus in the very beginning for that. That's one key aspect of ACI. So it's very easy to make changes that apply to a very large infrastructure if you happen to have one. But it's also an infrastructure where it's easy to make self-service portals for people to instantiate their own network on the fly and so on. The other key aspect of the ACI fabric is that it's designed with this policy model. The policy model is the definition of which security zones are in place and how they're supposed to talk through filters. So in this simple example, you have something that defines the outside network, then which filters or which kind of layer 4, layer 7 devices you want to have the traffic go through before the client requests get to the web servers. And then here, this is defining how the web server security zone is allowed to talk to the app's server security zone and so on. So there is this model, this policy model, that is what you end up configuring on a regular basis and provision and decommission and so on. Now, underneath, the forwarding is based on a VXLAN infrastructure. So all the leaves are basically VXLAN tunnel endpoints. And they provide, all the leaves here provide the default gateway to the servers, to the VMs. And the same default gateway address is available anywhere in the fabric. So you don't have to keep in mind, oh, the VM is on this leaf. What's the IP address here for the default gateway? It's the same wherever the VM moves. So there's this concept of anycast gateway. Through VXLAN, the forwarding allows you to have both layer 2 connectivity as well as layer 3 connectivity. So if two VMs need to communicate at layer 2, the transport is a VXLAN VNID, which identifies a layer 2 domain. If communication happens as a routed communication, then TTL is decreased, and so on and so forth. But underneath, the transport is always VXLAN frames. So this is showing traffic from one leaf to another one, or traffic switched locally. And in terms of going back to the policy model and going back to how workloads are allowed to communicate, the definition is based on this building block called an endpoint group, or EPG for short, and contracts. And so you could think of contracts as a classic ACL, with the key difference that instead of entering source IP and destination IP, the configuration is based on source and destination EPG, and which filters are allowing the traffic, or which firewall devices or load balancers are meant to be in the path. Okay, so the classic contract would be, let's say, allow port 80 or 443 from external EPGs to EPG web. But then you could also decide to just say, no, I want to have either for all the traffic or for a specific set of ports, I want to have the traffic filtered by a real firewall, right? So a Palo Alto, for instance. So this is how the policy model looks like. Now, you have to also define which workloads end up into each one of these security zones. So there's a key configuration that consists in defining the classification of the traffic. So for traffic that arrives to ACI through routing devices from the outside, the classification is based on IP network and mask. So you would define, this subnet belongs to this security zone, and you could have multiple of them. There's not just one external EPG. You could have hundreds of them to categorize the traffic coming from the outside into multiple zones. Now, for the workloads directly connected to the ACI fabric or connected to the ACI fabric via virtual switching and these kind of things, you can do more sophisticated classifications. So the simplest option is to say traffic from this port and this VLAN is this security zone. But you could also say traffic from this IP is this security zone and not this one, or traffic from this MAC address is in this security zone. Or you could go all the way to say this VM attribute, like this VM name or some label you put onto the VM belongs to this security zone or a different one. Okay, so the classification can be based on many levels of granularity, and it's also available for both physical servers as well as virtual servers, and you can have endpoint groups with a mix of physical and virtual servers, and they're all classified in the same EPG. It's not a problem at all. So based on that classification, then you can have security rules, as we said in the beginning. So you can say which ports are allowed between the security zones. But not only if workloads are connected to the same host or the same leaf, but also if workloads need to communicate across different switches, across different leafs, or even across different data centers, since we also allow you to carry VXLAN across the planet, okay? And that information is, the security zone information is part of the VXLAN headers. So there's a source class ID, which defines the source EPG, basically. And the packet carries also the information about which VRF it belongs to. And also, there are some additional bits that indicate whether the filtering has already occurred or has yet to occur. Because it could be that on the ingress switch, there is enough information to know which security zone the VM belongs to, but maybe there's not enough information to figure out where it's going to in terms of security zone. So if that's the case, the packet can still be sent, indicating that the source filtering has not been applied, and then it's the work of the egress leaf, the egress switch, to apply the filtering for that traffic. Okay, so that's how the information, the security information, is carried across on the data plane. Now, the policy model is part of a bigger picture. So not only you have the definition of endpoint groups and contracts and so on, but all these building blocks, all these configuration elements, they are part of something called the tenant. ACI lets you define configurations based on tenants. So whenever you define some new security configuration for your endpoints, it's always part of a tenant. So ACI is designed to be a multi-tenant fabric. Within the tenant, there is the definition of a VRF or more. So you could have one or more VRFs. And within the VRF, you define the layer 2 domains, the bridge domains, which you could think of as the classic VLANs. But they are VLANs based on VXLAN VNIDs. So they are bridge domains, meaning routed constructs. But they look and feel like the classic VLAN. So it's a layer 2 domain. It does layer 2 forwarding and these kind of things. And then the security zones further carve the bridge domains into smaller subsets. So here you have EPG web and app as a subset of bridge domain 1, and EPG database as a subset of the bridge domain 2, just as an example. So you can have more than one security zone per layer 2 domain. So this is a bit different than classic networks, because in classic networks, you would often define different VLANs to segment traffic that belongs to different security zones. In ACI, to define 2 different security zones, you don't create different bridge domains. You can if you want, but you're not obliged to. You would define a bridge domain and then carve it up into multiple endpoint groups or into multiple security zones. Okay? So let's talk about now the insertion of firewalls, and more specifically, insertion of Palo Alto into this picture. ACI has multiple ways to define how you can insert a firewall or a layer 4, layer 7 device in the path in general. And some of them are probably very familiar to you because they look and feel like classic networking. But then there's the one that we really like to draw your attention to, which is called policy-based redirect or Servicegraph Redirect. So let me quickly give you an overview of what Servicegraph with PBR is before we talk about all the various flavors of integration. So with Servicegraph Redirect, what you normally configure is just regular VRF and bridge domains and EPGs for the connectivity of the servers. And whether you're going to have a firewall or not in the picture, you don't need to make anything different. I mean, you just configure the bridge domains as you need to. You just configure the VRFs as you need to. You don't have to think about, OK, the default gateway may be the firewall, or, oh, I need to create 2 VLANs to pass traffic through the firewall. No. You define the networking connectivity for your servers just like you would regardless of firewalls or layer 4 devices. Now, how then traffic goes through a firewall with this kind of design? Well, we have this feature called Servicegraph with PBR, where you can say the traffic from this security zone to this security zone, instead of having to be routed in the classic way by looking at the routing table, it should be redirected to these other bridge domains where only the firewall is connected. Okay? So when ACI forwards the traffic, it checks the source EPG, destination EPG, and then it can say, oh, then I shouldn't do any routing here. I should just do redirection to the firewall. The firewall then do whatever it needs to do and forward traffic to where it needs to go. Okay? So with this kind of design, the default gateway for the servers is not the firewall, it's ACI. Okay, so ACI is the default gateway. The firewall doesn't have to be in the same bridge domain or in the same VLAN as the server. It can be if you want to, but it doesn't have to. Yeah, in other words, you can insert the firewalling capability when you want without having to re-engineer the way you divided the network into layer 2 domains or the way you define the default gateways, okay? So that's one of the interesting points about using this model to insert the firewalls. But now let's take a look at the various deployment models, because PBR is just one of them. But I believe the other ones would be no news to you. It's the classic way to insert firewalls in any network. So you can use a design where the firewall is the default gateway. So the firewall will be connected to an EPG on the same BD as the servers. And the server's default gateway will be, as you see here, the firewall interface itself. So this is how often people deploy firewalls as default gateway for the servers, and you can do the same in ACI. Another way to insert a firewall, which is also popular, is sometimes referred to as VRF sandwich, meaning you could define different VRFs and then put the firewall between these VRFs. And in this case, the default gateway for the servers will be ACI, but then the configuration would be the classic routing configuration. You would have maybe static routes or dynamic routes between ACI and the firewall, and then between the firewall and ACI again on a different VRF, and so on. So all the traffic in both cases would go through the firewall in both designs, okay? Here, there would just be a bridge domain configuration, and here you would have to allocate different VRFs, and then we have this construct called layer 3 out, which is just a wrapper for routing configurations. So that's where you put your BGP or your static routes, and you would need two, one per VRF, to pass traffic through the firewall. So these are, if you deploy a firewall in routed mode, in layer 3 mode, these are the classic way to add the firewall. And then the last one, which is what I would say the newer option, and also maybe the most interesting one, is the one we described in the beginning, which is called policy-based redirect. So the default gateway for your servers will be ACI, but then you don't need to configure routing between the firewall and ACI. The forwarding will be based on redirection, and then on the firewall, we would have just a static route to ACI. So traffic knows that to go to wherever it needs to go, it needs to be sent back to ACI. Okay? So traffic here flows through the firewall, not because of dynamic routing, not because of static routing, but because of redirection. And from the firewall back to ACI would just be a default route, typically, right? So this is based on a building block, a design configuration that in ACI that is called Servicegraph. You need to use this construct to make the traffic go through the firewall. Now, for insertion of layer 4 devices, layer 4, layer 7 devices in layer 2 mode or layer 1 mode, you can also define them in ACI. You can configure them in ACI in a classic way. So one way to do so is to define two bridge domains. So in a classic network, you will define two VLANs. In ACI, you define two bridge domains, but it boils down to the same. The default gateway for your servers will be ACI, but on the opposite side of the firewall. So it will be the ACI interface on this layer 2 domain. And this layer 2 domain would just be pure layer 2. There will be no routing interface here. So all traffic will flow through the firewall. But we also have the option to do redirection, like PBR, also for the layer 2 mode, which is something quite new. So in this case, you would not need to create two bridge domains to pass the traffic through the firewall. So your servers will be on their bridge domain. The default gateway will be ACI. And yet ACI is able to redirect the traffic through a layer 2 device. So there will be still 2 bridge domains for the layer 2 device because the layer 2 device expects 2 bridge domains. But they don't need to be the same ones as where the servers are. So what's nice about this is, again, that you could have a network designed for server connectivity, and you add later on the redirect to a layer 2 device, to a layer 2 firewall, without having to split bridge domain where the server is. So that's one of the reasons why you would want to do this. And then there are the benefits of policy-based routing, which will describe additional benefits of policy-based routing, which we'll describe in a few slides. Let me zoom in on the layer 1, layer 2 PBR, layer 1, layer 2 service graph redirection. It's another way to look at the traffic flow. So imagine you have 2 servers in the same layer 2 domain, and they can be on the same layer 2 domain and be part of 2 different security zones because you can use endpoint groups. So you have EPG client 1 and EPG server 1, which are a carving of this bridge domain. So you have these 2 security zones, and then you put service graph to say, even though they're in the same layer 2 domain, they need to go through the firewall, and the firewall is operating in layer 2 mode. So for you to do that, you will need to define these other 2 bridge domains, which are not for the endpoints, not for the server's connectivity. They're just for the firewall connectivity. And then the service graph configuration would say that traffic from this EPG to this EPG has to go through this path. Okay? So here the device is a layer 2 mode, but as you notice, we're not bridging VLANs where the servers are. So that's how the topology looks like. And ACI will rewrite the MAC of the traffic here to be the destination MAC, and can be like the opposite bridge domain. So the traffic is obliged to flow through the layer 2 device up there. So it's a different way to insert layer 2 devices in the path. And one of the advantages is that if you have layer 2 firewalling in the classic networks, you're basically bridging VLANs. And as you know, when you bridge VLANs, there's also a chance to introduce potentially a loop. With ACI, you're doing the same work of bridging VLANs, but in dedicated bridge domains, which arguably you could also introduce a loop there. But the difference is that you're not going to bring a loop that consumes bandwidth on this bridge domain, but it will be separate bridge domains. So the chances to affect more servers are limited and constrained. So that's one interest of doing this kind of, following this kind of implementation. But let's then focus on what are then the reasons to use, for instance, Service Graph Redirect, Service Graph PBR, versus classic deployments. So we mentioned some of them. But let me highlight a few additional reasons. Well, first, you can say in ACI that not all traffic has to go through the firewall. You could say only specific ports, right? So you could say, I don't know, ICMP could be direct between EPGs, and then port 80 could have to go through the firewall. That's one reason. The other one is you could say that traffic from, say, an endpoint group and the outside must go through firewall 1, and then this other EPG to the outside has to go through firewall 2. Or you could also say, I want traffic from, for port 80 to go through one firewall and for port 8080 through another firewall. And all these EPGs could be the same bridge domain. So that's the difference with classic networks. You don't care anymore about the layer 2 domain. You care about the security zone, the EPG. One more reason, this is more for the load balancers. If you don't want to do source NAT on the load balancer, you can use Service Graph Redirect to return traffic through the load balancer on the way back from the servers to the clients. But one of the key, as we said in the beginning, one of the key interests of doing Service Graph Redirect is the flexibility that this gives you at the design level. Meaning, even if you want to deploy security in stages, you don't need to plan day one for the fact that you need to add a firewall later on. You can design your layer 2 network or your layer 3 network from the beginning, just like you would without a firewall and then insert the firewall later on for all the ports or for specific ports, and you can do that at a later stage if you want. So this gives you this extra flexibility. And then ACI also gives you some extra flexibility with Servicegraph Redirect, because you could have servers of the same subnet filtered through the firewall, so you don't have to, again, split the bridge domain in two. But you could even go as far as saying that servers within the same security zone, they have to go to the firewall. So you can also do service graph redirection inside of the same security zone, like what you see on the right of this slide. So that's another interesting point. You can also, this also gives you the flexibility to attach firewalls in the topology wherever you like. They don't have to be on the same leaf of the servers. They can be on any leaf of the fabric. They could even be in a different data center if you want, because ACI can also give you that flexibility. And the interfaces of the firewall can be on, you can put them on a dedicated bridge domain so that multiple layer 2 domains will all use the same interface, so you don't have to configure one per bridge domain on the firewall. But you could also have the interface of the firewall on the same bridge domain as the servers if you so desire. So you also have that flexibility. And it doesn't have to be that the firewall is the default gateway, okay? So you could have an interface of the firewall on the same layer 2 domain as the servers, and yet use the redirection to push traffic through the firewall. So you can have both. Now, another extra advantage of Servicegraph Redirect is that if your firewall pair is not enough, and if you want to scale the capacity of the firewalling infrastructure, ACI allows you to add more than one firewall, and ACI will take care of hashing traffic through multiple firewalls and do it in a symmetric way so that your flows are not going to, in a symmetric way to the firewalls. So you can do redirection and combine it with the ability to hash, hundreds of firewalls if you so desire, with symmetric redirection. So instead of one firewall, you can have, in this example, 3 of them, and then ACI will take care of to do load distribution across them. And what if one of these firewalls goes down? Okay, so ACI does monitoring. So for the layer 3 mode, the monitoring can be based on ICMP, TCP, etc. For the layer 2 mode, there's also a layer 2 ping, which checks whether the firewall is there. And then if the firewall is not reachable, ACI can take it out of the pool, and it will rehash the flows that were going through that firewall to one of the other links, okay? So that only the flows of the firewall that went down are affected by the failure. It's not recalculating the hash for the entire pool. It's just reallocating the hash for that specific firewall that went down. And then you can have policies that decide, okay, if so many of the firewalls went down, then take firewalls completely out of the equation, and you can decide whether you want to fail open or fail closed, up to you to decide. And then you can say that the entire service can be brought back online once you have more than a certain % of available nodes. And then, once you go to more than 80% of the nodes are available, then you can say, okay, now we do PBR again, and traffic has to go through the firewall. So you also have all these levels of control to define when the service graph redirect should be operational or not, and then if it's not, you can decide whether you want to have a permit or a deny for the traffic. Another benefit, another problem that this technology solves is the security across multiple data centers. Because in a classic design, if you have multiple data centers and traffic may be entering from these firewalls and then going to the other one, there's always the risk that the return traffic is going through the local firewalls, and this will not work, right? Because traffic flows will not be known to the firewalls here. firewalls here, and then traffic will be dropped. ACI allows you to solve that problem by relying again on this technology, on Servicegraph Redirect, so that traffic that is destined to this endpoint may be entering through this path, and then the redirection occurs on this leaf, so that traffic goes through the local firewall, and then if the traffic happens to be going to the opposite data center, the redirection is applied here, so the traffic is filtered in both directions through this firewall. So this ensures symmetricity also when you have dispersed data centers by relying on the Servicegraph Redirect feature. You can also control traffic and make sure it enters directly where you want to. So there's no need to do this path. But if it happens to be doing this path, this is solving that problem. So these are the scenarios that Servicegraph Redirect helps with. Now, needless to say, we're also investing a lot and developing a lot for the integration with cloud. So you also find the Servicegraph feature available when you connect your workloads also on Amazon, for instance. But they're just for you to know. We're not going to go any deeper on this particular aspect of the design. And now let Jaimin talk about the specific integration with Palo Alto.
Thank you, Maurizio. All right. So quick poll again. How many of you are doing east-west firewalling? Like how many of you are inspecting the traffic in east-west direction? All right, about 4 or 5 hands, about 10% of you. All right, good to know. And how many of you are using virtual firewall to do that? Anyone? Right? 1 out of 4, right, 20%. Rest of you are using either VSys or leveraging the same firewall? Yeah? OK. All right, good to know. Thank you. So these are the 3 key benefits of our integration with Cisco ACI. The first one is the deployment flexibility. Second one is you'll be able to secure multi-tenant data centers. And the third one is you'll be able to secure dynamic workloads. And I'll double click into each of them. When I talk about deployment flexibility, it's all about form factor level freedom and also operational mode level freedom. Our integration with Cisco ACI works equally well with both hardware firewalls and virtual firewalls. Literally 0 difference. So you have the freedom to pick either hardware or virtual, but the integration would work in both. You can also deploy our firewall in layer 3, layer 2, layer 1 mode, and it can be paired with layer 1, layer 2, layer 3 PBR, right? So both the modes, operationally and form factor-wise, it would work. When it comes to securing multi-tenant data centers, understand that ACI has a very nice multi-tenant capability in its architecture. Multi-tenancy is built into it from day one. So you can use the shared firewall. If you are using hardware firewall, you can have the hardware firewall placed in a tenant called tenant common. And then all other services, all other your application tenants can leverage the very same firewall. And you can redirect the traffic through that shared common firewall. You can use, if you're using virtual firewalls, then you can use zones to achieve the multi-tenancy. If you're using hardware firewalls, you have the option to use VSys. Other option that we are seeing among our customer base that they are using is for north-south inspection primarily, they use our hardware firewalls. But for east-west, they are increasingly using VM firewalls. So that's a choice. That's the trend that we are seeing, just FYI. When it comes to securing dynamic workloads, you will have data centers sometimes with bare metal servers, which are pretty static. But as you move from bare metal workloads to virtualized data center to containers, you will see that dynamicity popping up. And then you'll be challenged to have the security catch up with that. So you can use dynamic address group-based policies now that is well integrated with Cisco's ACI EPGs to update your IP to tag mapping. And what I mean by that is we have built this plugin architecture. So we have a dedicated Cisco ACI plugin in Panorama. You go to Panorama tab, and we have a demo for it. But you'll be able to download that in less than 30 seconds, install it, and get this up and running. that is called unmanaged mode of integration. There's also a managed mode of integration with device package, but we highly recommend you to adopt unmanaged mode of integration because it's way more simpler, and you'll be able to get up and running and go from 0 to in production in just almost no time. This ACI plugin allows you to write dynamic address group based policies on top of multiple Cisco ACI constructs. So Maurizio showed you the tenant level hierarchy. So you can write dynamic address groups on top of tenants, application profiles, EPGs, and if you want to do microsegmentation, then there is a construct in ACI called micro EPG. So you can write dynamic address groups on top of micro EPGs. So if you are steering the traffic between the micro EPGs belonging to the same bridge domain, you'll be able to steer that traffic through the firewall and achieve microsegmentation at layer 7. Right? It's super easy to configure, and we'll show you in a demo. If you have multiple data centers, from the very same panorama, you can manage up to 16 independent ACI clusters. So up to 16 independent data center sites with ACI, you'll be able to manage from one panorama, and that's really powerful. Well, a picture can say 1,000 words, but we believe demo can say 10,000. So with that, Maurizio, why don't you run it through the demo?
Okay, so this is the, so it's a recorded demo. So you'll see the configuration steps, and it's all based on this topology. So the topology consists of 3 instances of Panorama, of Palo Alto firewalls. And then we have here the security zones. So the default gateway for the servers is, so the servers are spread across these 3 security zones. And you will see these IP addresses in the demo, so it's important to remember. And this is showing that there's a contract between EPGs with redirect to the Palo Alto firewalls. VZNE here means it's a concept of ACI where if you want to have a contract for all the EPGs, you just use VZNE. It's just an any. But in the demo, we're just going to show you the configuration. And VZNE is just for you to know, but maybe it's going to be useful. Well, in fact, we didn't say anything about it, so let me just clarify for a second. So imagine that you want to redirect all the traffic, not just between 2 EPGs, but between all the EPGs. You want it to go through the firewall because that's your default security configuration. An easy way to do it is to configure it with the VZNE concept. So it's one-line config where you say any to any, it has to go through the firewall no matter what. Okay, that's very convenient configuration option. Okay, so let's take a look at the configuration here. So I think the video will start. Yes, it is already started. So here we want to have a redirect that says all TCP traffic within the VRF has to go through the firewall panorama. And so how we do that? Here you have all the different endpoint groups, a web app and database. So you need to have a contract, and the contract is called here any. Okay, and so this is actually what I was mentioning before. We use this VZNE concept to say all traffic between all the EPGs. For TCP traffic, send it to the firewalls. And then there's another element of the contract that says for ICMP, don't send it to the firewall. You see this entry is empty. And this is the configuration of the service graph. That's where you say, I want to have this firewall between provider and consumer EPGs. Now notice that it's made, so notice that this is made of 3 firewalls. You saw there were like 3 firewall instances. So here we're looking at the Palo Alto configuration. This is what you would enter to connect to ACI. So this is the name of the IP address of the API controller and the credentials. And then if you look here at this, you see here the different Palo Alto VMs. And then you could configure an address group, type dynamic, and pull out which EPGs you want that address group to be based on. So what this does is it allows Panorama to pull the information from APIC about which IP addresses are present in an endpoint group. So you don't have to type the IP addresses manually, and if these IP addresses are changing, they are dynamically updated. So this is an example. These are the 3 EPGs that you have in ACI that have been discovered by Panorama, and you see that the IP addresses inside of them are the ones that are present on the actual fabric in ACI. So this allows communication by using the EPIC APIs so that the security configuration, security policies are based on the endpoint group names instead of being based on a list of IP addresses. Okay? So this is the security configuration. Now we can try to connect from web to app here with HTTP, and you see that it's working because it's allowed. But now we can modify the security policy on Panorama directly. So we can remove HTTP. So only ICMP would be allowed now, but ICMP anyway would not go through Panorama, would not go through the Palo Alto firewall. Okay, so now this configuration is pushed. Okay. Okay, now you see it's been updated. So there's no HTTP allowed anymore. So now if we try to pull that page, it doesn't work anymore. But now if I go to the app machine and try to connect to the database here, HTTP is still allowed because the other access list entry was still allowing it. Right? So this is all done without having to type any IP address. It's all done by using the EPG information directly from the Panorama configuration page. So this is, gives you an idea of what happens and what's, there is dynamic communication. So in Panorama, you see the security zones, and you can just use those security zones directly into the, as an address group and use them indirectly into the ACL configuration.
Thanks, Baiju. All right. So in lieu of customer, I have his slides where we will be talking about some of the real-world deployment. And this is real, where customer, they participated in our beta program. They are now in production with our Cisco ACI plugin. And this is what their architecture looked like. They had one tenant. They had multiple tenants, but let's just focus on one tenant. They had next-gen data center tenant, and they had one VRF under it, NGDC VRF, and they had 3 application profiles. Those 3 application profiles were OpenShift, because they had Kubernetes deployment, so they had OpenShift EPG, and they also had DMZ and non-DMZ applications, right? 3 different application profiles under the same tenant, same VRF. Different EPGs, and they also had VMM domain integration because most of their servers were running on ESXi, so they had VMM domain integration with EPIC, and they were well integrated with VMware on that front. Now, Palo Alto Networks Firewall was sitting at the perimeter, north-south perimeter, and it was connected. It is now connecting to EPIC. But if you look at the use case they were trying to solve was, hey, how do we secure our north-south traffic? And how do we really make it so dynamic and easy so that we don't have to update and worry about this Kubernetes workloads coming up and going down? And because Kubernetes workloads, the container workloads will just come up, will be spun up by application developers and will be spun down. And the workloads that were mainly deployed here were internally by their developers. So it was very difficult for them to keep firewalls state in sync with that EPIC state. So here, OpenShift load balancer VIPs were only listening to HTTP and HTTPS. DMZ also, they had F5 load balancer where it was listening to HTTPS, and non-DMZ load balancer F5 was listening to on any ports. They had 2 options. The option 1 was out-of-box automation. So customer literally wrote a script offline to poll EPIC every now and then, every few seconds and every few minutes to find out how many endpoints have come or registered under that EPG, Kubernetes workloads, or even VM workloads. And then they would write Panorama API calls to push those endpoints into Panorama dynamic address groups. So it was really cumbersome, and that means they had to do more coding. It was out-of-box automation, so it was the script that they were maintaining themselves, and it took a lot of time. They also had the responsibility to maintain those scripts, and it was delay time, and administrative complexity was just too much. The other solution, when we developed the plugin and they adopted it, was they were now able to create those dynamic address groups with the EPG association, right? Both EPG and micro EPG. So they didn't have to code every time when there is new enhancement, because it is now Palo Alto Networks tech-supported feature. Rules become effective as soon as endpoint is learned in ACI. And in the plugin of Panorama, you can configure the interval at which Panorama should poll ACI. So that plugin polling interval was also configurable. You can choose anywhere between 30 seconds to 24 hours, depending on how dynamic your environment is. If you're not rolling out applications as fast, then you can keep that time a little bit high as well, right? And in this case, the Panorama downtime didn't affect the traffic with only new learning. The other use case was they wanted to have OpenShift servers accessing infrastructure tools like DNS and some of the common services, DNS, DHCP, syslog, and other tools. The same with DMZ servers. They wanted to make sure that it can access only common services and not any other apps. And if somebody from the DMZ side wants to access other apps, they will provision that only on demand. But in non-DMZ case, where it is more of a trusted domain, they can allow any access. Again, two solutions, and they had two options. With the earlier solution, for multiple years, they have been stuck with that script, which they developed in-house, and they ran into the same challenges. But when they deployed our plugin, Cisco ACI Cisco ACI's dynamic endpoint learning was happening inside Panorama. The additional part that they really liked is we were not only pulling the tags for endpoint groups, but we were pulling the tags also for application profiles. So if you want to write less granular policies in Panorama, not just at the EPG level, but you want to just say tenant 1, between tenant 2, this should be my security profile and policy, you'll be able to achieve that too. If you want to write it at application level segmentation, you can achieve that too, right? You don't have to do micro segmentation at EPG or micro EPG level. You can level up a little high. Right? The third use case was really interesting. Here they wanted to protect east-west traffic as well. And I highly encourage you to consider east-west traffic protection as well with the next-gen firewall. They had two apps. In the DMZ app, they had default deny policy between those apps in the DMZ. Application can talk only to the dependent apps on that DMZ, but not anywhere else. The specific words like HTTPS and HTTP were allowed by using the contracts in Cisco ACI, but they wanted to control the access between those apps where the communication. So they were denying wherever they can deny using ACI itself, and that's our recommendation too. If you can deny the traffic right there in the network, by all means do that. But when you start allowing the traffic, that allowed traffic within the east-west needs to go through the firewall for deep packet inspection. So they had two options. One, use ACI layer 4 policies to stop the traffic. Obviously, it was administrative complexity was involved because they were the security team. They had to work with network team to change the contracts every now and then. Versus, they had another option with our Panorama integration where they just implemented Cisco ACI PBR. So policy-based redirect, again, yet another recommendation for you. And firewall policies now were not just at layer 4 level, but they were layer 7 policies. And they were able to leverage all the firewall features, all the advanced next-gen security features, such as threat prevention and wildfire. Right? So those were the 3 use cases deployed in real time, in real-world situation. Some key takeaways from this session. With this integration, I think we have simplified not only just the operations, but we have simplified the automation. Automation is usually done to simplify the manual tasks, but in this case, the customer eliminated their own automation, the script that they were leveraging. So we have simplified the automation. We have automated the automation itself. Cisco ACI really provides that flexible and scalable service insertion architecture. The real good feature that I liked is the symmetric PBR. So with symmetric PBR, you can horizontally scale the firewalls, and ACI can take care of load balancing the traffic and spraying it across. So if you have dynamic environment, you can use virtual firewalls and scale out. Again, multiple options were proposed here. Use PBR, that's our recommendation. You can use now PBR in layer 1, layer 2, layer 3 mode, and you also have operational mode level flexibility. You can deploy the firewall in any of this mode, and we are supported. Consider VM series or next-gen firewall to protect your east-west traffic and scale the security on demand. 3 next steps for you. You can install Panorama plugin today. It's already generally available, and I was talking to another customer who is here. To go from 0 to in production, it will take you 2 minutes. The installation of the ACI plugin itself is like, consider 30 seconds. You can connect to Epic in 1 minute, and within 1 minute, you will have all the tags pulled in. So you'll be able to start writing the dynamic address group-based policies and pre-populate those security policies even before the traffic is steered. So you can write the security policies irrespective of whether the firewall is in the path or not in the path. And then you can go to the security network team and then have the Epic do the steering, right? And if there are any problem, we are here to learn from your experience, so do share with us what's your experience, what issues you are running into. We have another maintenance release coming up on Cisco ACI plugin, which will have very good, cool features, but it's part of roadmap, so I'm not discussing it today. But just wait for it. You'll be able to upgrade the plugin in a non-disruptive manner. Plugin upgrades in Panorama are non-disruptive. It will not cause any traffic disruption. And I just had a session on microsegmentation, but if you want to learn more about microsegmentation best practice with ACI or even in general, watch the video. The video will be also made available. The session was at 8 o'clock, but it's now recorded. Okay? We are here to learn from your feedback. That's how Maurizio and I grow professionally and personally, from your feedback. This is how we improve our presentation, something that you like, did not like, what can we include more in the next session. So please give us your feedback. Thank you so much. And for Q&A, I think we'll make ourselves available. Thank you.